Greetings everybody, and we're just going to have one or two videos here about rational exponents, and we will wrap it up briefly. So here we are, rational exponents. What the heck are these things about? Because obviously we are familiar with the integer exponents, such as 4 to the power of 2, 8 to the power of -1, and x to the power of 0, which you could figure out probably in your head what these all represent. In other words, 16, 1 over 8, and 1. But with rational exponents, in other words, fractions or even decimals, this is a little bit more complicated. So what the heck does a rational exponent mean? Okay, well, let's take a simple example and demonstrate a basic thing we already know about multiplying powers, and that is when you multiply powers, we add exponents. In other words, x to the power of a half times x to the power of a half is just x to the power of 1, because you add the exponents. 1/2 plus 1/2 is just 1. Pretty simple. Well, let's plug in some real numbers and see what we get. Okay, so for example, we could use 4. So 4 to the power of a half times 4 to the power of a half is just 4, essentially. So in other words, we have two identical numbers multiplying together to get 4. What are those two numbers going to be? Well, obviously, 4 to the power of a half and 4 to the power of a half have to be 2 each, because we know that 2 times 2 is 4. Does this work for other numbers? Absolutely. Here's another example we could use. 9 to the power of a half times 9 to the power of half is equal to 9. In other words, one number multiplied by itself equals 9. That number must be 3. And so in both cases, with both 4 and 9, to the power of a half, it basically makes us take the square root. And this is true for any set of numbers. You can even plug it into your calculator and put the exponent of 1/2 for any number, and you'll get the square root of that number. And so if you look on your calculator, you probably have either a x to the y button, or you have that hat button. And if you plug in 25 to the power of 0.5, which is 1/2, you will see undoubtedly the answer is definitely 5, because 5 is the square root of 25. And that's it, really. I mean, that's kind of the main point. So the exponent of 1/2 just means to take a square root. But what about if it's not 1/2? What if it's 1/3? What do you think that means? Well, if we take a number and raise it to the power of 1/3 and multiply it by itself, well, we would add those exponents, but those don't add up to 1. But if we put a third one in there, now those exponents all add up to 1. 1/3 plus 1/3 plus 1/3 is 1. So similar to the square root, I'm taking three identical numbers, multiplied them by themselves, so one number times itself 3 times, in other words, and I got, well, whatever my number was. Let's use some real numbers here to demonstrate that. Okay, so 8 to the power of 1/3 times 8 to the power of 1/3 times 8 to the power of 1/3 equals 8, 8 to the power of 1. So what does 8 to the power of 1/3 mean? Well, it must mean that whatever number you multiply by itself 3 times, so x times x times x, has to equal 8. In other words, it has to be 2. Which means then that the power of 1/3, or an exponent of 1/3, doesn't mean the square root, it means the cube root. And just like that there. Okay, well, let's back up just for a second. We said that the 9 to the power of 1/2 would be 3, because that's the square root of 9. And you'll notice that I have a little 3 here and a 3 here. There's a 2 there, and we don't write it just like we don't typically write the exponent 1, but there's actually a 2 there as well. So in other words, any exponent 1 over something, whatever the number on the bottom is, the denominator, becomes this little guy here. And by the way, that number is called the index. So the denominator becomes the index. So for any fraction, or any, power to the power of 1 over n, it's the same as saying the nth root of x. So it doesn't matter what the denominator is, you just take that denominator as being your index, and you can solve any problem. Even that silly one on the right there, which I'm sure you all did in your head. In any case, let's have a look at what happens when you don't have 1 as your numerator, though, because that causes some confusion. Here we go, next video, and probably the last one too.